Alright, welcome to my week 8 problem 2 video explainer. So in this problem, we have a grating that is ruled with 10,000 lines per centimeter, and it is used to diffract light from the sun. So there's 4 parts of this problem, and in the first part we are trying to find out what angle would a certain length line of helium first be observed. And that length is given at 587.5 nanometers. So, given that we can use the equation a plus b times sine theta equals n lambda, where a plus b is the grating element, theta will be the diffraction angle, n would be just the order, and lambda, which would be the wavelength of the source. So first, we're going to calculate the grating element, which is just going to be, as we were given, 10,000 lines per centimeter, and we will find a value of 10 to the negative 6 meters. And once we have that, we were also given lambda, which was 587.9 or 587.5 nanometers for the line of helium. And now, just inputting those variables and taking the inverse sine of that ratio, we find that the angle that line of helium would first be observed at is 36 degrees. The next part asks if there would be a second location where this light is diffracted, and if we raise the order to 2, we find that this equation could not be solved, as we'd be trying to taking the inverse sine of a number bigger than 1, so that just wouldn't work out. So the final answer is there is no second location. And now the problem asks to explain the difference between an absorption and emission line and whether or not they can be observed at the same point. So an emission line would involve electrons of typically an excited atom that move between energy levels, and they would return to the ground state. And in an absorption line, electrons of an atom gain photons, thus increasing their energy levels. And they could, in fact, be observed at the same point. And finally, we're given the task to explain why this line was first seen on the sun and not on the Earth, and how it is related to escape velocity. So, due to the fact that the escape velocity of the sun is greater than that of the Earth, we can concur that this line was first seen on the sun. And just some of the tricky parts of this problem specifically just involved finding that diffraction angle, knowing what equation to use, and getting the grating element. And other than that, finding the difference between absorption versus emission lines. And then also the last part involved referring to some external sources, just because we have not really covered the correlation between escape velocity and the appearance, I guess, of this line on the sun versus that of the Earth. But yeah, and then this just relates to what we've been doing in class with regards to wavelengths, grading, trying to find diffraction angles, that kind of stuff. So yeah, thank you.